Hey everybody, Mr. Judson here. So today our goal is really to take everything we've learned about the first derivative test, second derivative test, when is it concave up, when is it concave down, where are the points of inflection, are there any maximums or minimums, all that, asymptotes, everything. Put it all together and use that to try and analyze and graph a function. Okay? So these are not going to be quick problems. They're going to take us some time to get through. We're going to have to be patient and just know that it's going to take a while. All right, so some things that I know. Number one, I know right off the bat there's a vertical asymptote at x equals 2. So I just want to start listing things as I figure them out. So vertical asymptote at x equals 2. I don't believe this factors because two numbers you multiply to get 4 and add to get a negative 2. I don't think that's going to work. That doesn't mean that there aren't any zeros for this function. What it means is I would probably have to do the quadratic formula to find those. They're going to be some decimal number. Okay? So I still may want to do that just so it's another piece of information that I have for my graph. Okay? So if I was looking for the zeros, I would say, remember that saying that the only way a fraction equals 0 is if the numerator equals 0? That's what I'm looking for now. So if I want to set this equal to 0 and solve, I'm just going to use the quadratic formula, and I'm going to say negative b plus or minus the square root of b squared, that's 4, minus 4 times AC, so A times C would be 4, all over 2A, which is 1. Or 1 times 2 is 2. So at this point I can stop because I'm looking inside the square root and I see 4 minus 16. That means I'm taking the square root of a negative number. So that doesn't work. There are no zeros. This graph will not touch the x-axis. That's what we're saying. Okay? So again, piece of information. Y-intercept, that's always an easy thing to find. You just plug in 0 and see what you get. 4 over negative 2, that's going to be a negative 2. So 0 comma negative 2. All right, now we can start using our first derivative test to try and see if there are any relative maximums or minimums. Also, where is this function increasing or where is it decreasing? So, f prime of x. I'm going to do low d high. Derivative of the high part would be 2x minus 2 less high d low. So that would be x squared minus 2x plus 4. D low is 1. All over low squared will go. Remember, don't cancel these. You cannot cancel part of something that's being added or subtracted with something else. So we just got to work this whole thing out and see what we get. So if I FOIL this, I'm going to get 2x squared minus 2x minus 4x, so that's minus 6x, plus 4. And then minus x squared plus 2x minus 4. All over x minus 2 squared. I'm not going to multiply this out. So if I now simplify that numerator, I've got 2x squared minus x squared. So that would be just x squared. Negative 6x plus 2x, that would be a negative 4x. And 4 minus 4, those add up to 0, so we'll just get rid of that. All over x minus 2, that quantity squared. There's my first derivative. And so now what we need to do is we need to find the critical numbers. Okay? Where does this equal 0 or where is it undefined? Those are the critical numbers. That's how I know how to split up my intervals for that table. So if I factor the numerator, I've got x times x minus 4 over x minus 2 squared. So my critical numbers are going to be at 0 and 4. That's where this thing equals 0. And it's undefined at 2. Okay? So 0, 4, and 2. So if I have a relative maximum or minimum, it's going to occur at either 0 or 4. It's not going to occur here because the original function was undefined. We already know there's an asymptote there. But I still need to use that as a critical number because I need to know what's happening on either side of that asymptote. Okay? All right, so now I'm ready to do my first derivative test. So I'm going to break this up into some intervals. First number I'll hit is 0, so we're going to go from negative infinity to 0. Then I'm going to go from 0 to 2, and then from 2 to 4, and then from 4 to positive infinity. Alright, so I'll choose negative 1 in this interval, here I'll choose positive 1, here I'll choose 3, and here I'll choose 5. And then when I test those, I could plug into here, but this is going to be the easier place to plug it in. Right, where it's all factored. So if I put a negative 1 in there, well, first of all, let's just realize that no matter what we put in this denominator, we're going to square it, and that's going to become positive. So really, I just need to plug into the numerator and see what happens, and then just divide that by a positive. So if I put a negative 1 into here, I've got a negative 1 times a negative 5. So negative times a negative is positive. Divided by a positive is positive. And then I'll plug in a 1. So I get positive, here I'll get negative 3, so it's a positive times a negative, that's negative. Divided by a positive, that's negative. When I plug in a 3, I get positive here, still negative there. So that'll be negative divided by a positive, that's negative. And if I plug in a 5, I get a positive number here, positive number here. This is always positive, everything's positive. So we are increasing on this interval. Then we are decreasing, over here we're decreasing, and then we start to increase. So to me, that sounds like, okay, we're going up and then down, so there's a relative maximum at, what was that, 0? At 0 comma something. Well, we already know what goes there, right? That's my y-intercept. If I go back up there and look, my y-intercept is at 0 comma negative 2. When I plug a 0 into the original function, that's what I get. All right, so bonus, I don't have to figure that out. We already know there's an asymptote here. And then here we're decreasing, then increasing. So we have a relative minimum at this was at 4, so 4 comma something. I'm going to have to figure out what that is. Okay? So let me just go back up here to the original function. And just off to the side here, I'm going to say f of 4 is going to be 16 minus 8 plus 4. So 16 minus 8, that's 8. Plus 4, that's 12. If I put a 4 here, I get 4 minus 2, that's 2. And so what I got is 6. So there's that value. So one thing I just thought of that we didn't talk about, we did learn last year that if this exponent is larger by 1, then the denominator means we have a slant asymptote. So if you guys wanted to, you could go ahead and incorporate that in here as well. What I can do with this is just do some synthetic division to figure out where that slant asymptote is. So if I write down the coefficients, 1, negative 2, 4, and I do synthetic division with positive 2, right, because I'm dividing by this. Bring that down, then I'll multiply and add to the next. So 2 minus 2, that's 0. Multiply, you get 0, add to this, you get 4. This part right here is the slant asymptote. And remember, this was x squared, so you decrease your exponent by 1. So y equals 1x plus 0. Okay? Or just y equals x. That's our slant asymptote. All right, so it's just, again, another piece of information to help us out. If I didn't catch that, not a big deal, but you know, it's another piece of information. All right, so I know where my relative maximum and relative minimum are located. I know there's an asymptote between those. Whoops. I know there's an asymptote between those, and so you know, now I just need to check concavity, or are there any points of inflection? So, time to find the second derivative. So let's see, I'm just going to go back and remind myself of this. X squared minus 4x over x minus 2 squared. All right, so now I need to find the derivative of that. So f double prime of x is going to be, I've got to do the quotient rule again. So low d high, so x minus 2 squared. D high is going to be 2x minus 4. Less high d low. So I've got x squared minus 4x. Derivative of the low part, I've got to use the chain rule. We're getting everything bunched into one problem here. So bring the 2 down in front. Subtract 1 from the exponent, that's now a 1. Times the derivative of the inside, which is also 1. And that's all over low squared will go. So this will now be x minus 2 to the 4th power. All right. So one thing that I see, and this is really important to catch, if you don't catch this, from this point on it's a nightmare, right? But one thing that I see is that x minus 2 is a factor in every single term. So what I want to do is I want to factor an x minus 2 out of here and out of here. So I'm bringing that out. And what I'm left with is x minus 2 times 2x minus 4 minus, I took this out. I got all these 1's here. They don't do anything. I want to distribute this 2 to these two terms, and I also want to distribute the negative sign. So I'm just going to say negative 2 times each of these. That would be a negative 2x squared. Negative 2 times that would be a positive 8x. And then I've got x minus 2 to the 4th power. So now, because I'm multiplying by this thing, right? Oops, I need one more set of parentheses here. This factor is getting multiplied times everything inside this set of parentheses. I can cancel that with one of these, and this is now to the 3rd power. Alright, so here's what I get. If I FOIL this, I get 2x squared minus 4x minus another 4x, so that's minus 8x. And then plus 8. And then over here I've got minus 2x squared plus 8x, look at that, all over x minus 2 cubed. And so what I see is that those 2 add up to 0, and those 2 add up to 0. So that just simplified by quite a bit. So I've got f double prime of x is equal to 8 over x minus 2 cubed. So now I need critical numbers, right? Where does this equal 0? Well, the only way a fraction can equal 0 is if the numerator equals 0, which it can't. 8 will never equal 0. There's no variables in there. Or where is it undefined? Still undefined at 2. We know that because there's an asymptote there. So my only critical number is 2. So when I do my second derivative test, my intervals are going to be from negative infinity to 2, and from 2 to positive infinity. So I need a test number. I'm going to check the sign and then draw a conclusion. So this time when we draw the conclusion, we're trying to figure out, is the graph concave up or concave down? Okay. So my test number here will be 0. My test number here will be 3. If I plug in a 0, let's see, I've got negative 2 to the third power, that's negative 8. So a positive divided by a negative, that's negative, and we are concave down. If I plug in a 3, I get a positive 1 here. 1 raised to the third power is 1. 8 divided by 1, that's a positive number, so here we are concave up. And I think that makes sense because on the previous test, the first derivative test, we saw that we had a relative maximum, so we're concave down. Now, the way I drew this, it looks like there might be some points of inflection in there, but that would be wrong because it didn't equal 0. There are no points of inflection. Here I was concave up, which makes sense because I got a relative minimum. All right, now I need to produce a graph. All that work to produce a graph. I'm going to try and squeeze it in right here so that I can go up and see some of the other stuff that we have. So first thing I know is that there is a vertical asymptote at x equals 2. Right? It's one of the first things we wrote down. I have to go back up and look at all the information here. There were no x-intercepts, no zeros. I know I've got to hit this point, 0, negative 2. There was a slant asymptote at y equals x. Now if I missed that, I think I'm still okay. All right, but I'll go ahead and draw it in there. So let's see, if I do a diagonal like this, there's that slant asymptote. And I saw that there was a relative minimum at 0, negative 2. No, relative maximum, sorry. And my relative minimum was at 4, 6. 1, 2, 3, 4, 5, 6, right there. And we were increasing, then decreasing. Let's just go back and look at that. Increasing, then decreasing. Here we were decreasing, then increasing. And so that seems to fit the stuff that we're talking about here. Same thing up here. And then here I was concave down, here I was concave up. Okay, so everything that we found agrees with the picture that we drew. We're not crossing the x-axis at all. I did hit my y-intercept, which was also my relative maximum. And so I've got everything that I need here. Okay? Whew! That's a lot, right? All right, let's try another one. All right, so this one will be a little bit easier because it's a polynomial, it's not a fraction. But we still have to go through all those same steps. There just aren't going to be any asymptotes in this graph. Okay? So I'm going to let you guys try this one on your own. Okay? Go ahead and pause the video and see if you can work your way through this. I'll see you in about 20 minutes. All right, give it a shot. All right, so one of the things I see right away is that if I plug in a 0, everything goes to 0, and so this graph will go through the origin. So that would be my y-intercept. 0, 0. Now if I want to try and find some x-intercepts, some zeros, I can go ahead and do that as well. It would involve using some synthetic division. So I'm going to hold off on that for right now. I'm going to analyze this using the first derivative test, second derivative test, and kind of see where to go from there. All right, so first derivative, I'm going to have 4x cubed minus 36x squared plus 96x minus 64. Ooh, some big numbers. But I see I can at least factor a 4 out of each of those and get x cubed minus 9x squared. If I divide that by 4, I believe it's 24x, and then minus 16. So I'm trying to find my critical numbers, so I need to set this equal to 0 and solve. And so we're going to have to take advantage of synthetic division here. So we're going to need a little reminder. Let's do my synthetic division off to the side. I've got 1, negative 9, 24, and negative 16. And so when I do synthetic division, I'm just going to look at this real quick and see, let's see, 25 minus 25. We said last year that if these numbers all add up to 0, that means 1 works. So that's helpful. So I'll bring a 1 down, multiply, you get 1, add it to this, you get negative 8. Multiply, get negative 8, add it to this, you would get 16. And then 16 minus 16, that's 0. So there's one of my factors, x minus 1. Remember, this is a 0 right here. That's my critical number. So as a factor, I'm going to write x minus 1 for that. Still have this 4 out here. And then this would be, since this was x cubed, this is now x squared minus 8x plus 16. So if I factor that, I get x times x. I believe this is going to be a negative 4 times a negative 4. Yeah. So x minus 4, we'll say squared. There's my first derivative. So my critical numbers are at 1 and 4. And it's not undefined anywhere, so we're not worried about that. So now I'll do my first derivative test. I'm going to set up some intervals. We're going to go from negative infinity to 1, and then from 1 to 4, and then from 4 to infinity. So I'll choose 0, 2, and 5. And so now when I plug that back into my first derivative, so remember I always want the factored form, and I also want to remember that when we square something, no matter what I plug in, this is positive. No matter what, 4 is positive. So this is really going to determine the sign that I put here. Right? So if I plug in a 0, I get a negative 1, times a positive, it's still negative. If I plug in a 2, I get something positive, and this is positive and that's positive, so overall we're positive. And if I plug in a 5, I get positive, 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 everything's positive. So we haven't seen that happen very often where we get the same sign twice in a row, but it's happened on both of these last examples. So I think that's tells us that we can't just assume that these always alternate. We've got to make sure we check it out. All right, so we are decreasing, then increasing, and then we're still increasing. So that to me says that this graph is going to go down and then come up. So there's a relative minimum at 1 comma something. But then 4 was a critical number. That's where my derivative equals 0. So this thing is going to level out, but then turn and increase some more. Okay, so that right there is at 4 comma something. Relative minimum here. A spot where the graph gets horizontal, but there's not a relative maximum or minimum because this didn't change. All right, so again, I look at this and I go, well, I feel like I already know what most of this graph looks like, but I still have to go through and analyze the whole thing. That's part of the process, is to make sure we understand those rules and can use them. All right, so when I take the second derivative, I could take my factored form and I could find the derivative of that, but I feel like it's easier to go back up to this and just do the derivative one term at a time. All right? So let's see, we got 4, negative 36, 96, and negative 64. So f prime of x equals 4x cubed minus 36, 96 and 64. Minus 36x squared plus 96x minus 64. I gotta double check my signs. Positive, negative, positive, negative. Okay. Alright, so now I need to find the second derivative, which will be 12x squared minus 72x plus 96. So now I want to set this equal to 0 and solve so I can find my critical numbers for my second derivative test. So I'm going to go ahead and factor a 12 out of here. And I'm left with x squared minus 6x. Let's see, 12 goes into there 8 times. And so now what I've got is 12 times, here I've got x, I believe it's going to be minus 4 and x minus 2. That'll give me my positive 8, and negative 2x minus 4x will give me my negative 6 in the middle. So my critical numbers are at x equals 4 and 2. So if there's a point of inflection, that's where it's at. Okay? 4 or 2. So now what I'm going to do is set up my intervals in the table. And I've got from negative infinity to 2, from 2 to 4, and from 4 to infinity. And so we need to pick a test number. I'm looking for a sign and then my conclusion. Alright, so I'll choose 0 for this one, here we'll choose 3, and here we'll choose 5. I'm putting that back into my factored form of the second derivative. So if I put a 0 in there, I got a positive times a negative times a negative. Overall, that's positive, so we are concave up. When I put a 3 in, I get positive times negative times positive. So that means there's only one negative sign, so we're negative overall. And that means we are concave down for that part. And then if I put a 5 in, positive, 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 we are back to concave up. So there will be a point of inflection at 2 comma something, right? Since our concavity changed, we have a point of inflection here at 2. I'm going to have to plug that back into the original function to see what my y value is. And there's also a point of inflection at 4 comma something. Alright, so let me go back and plug those numbers into my original equation. I guess I still got to plug these ones in as well. Ugh. That just does not look like fun. So we get to use a TI-84 calculator on our test. And so I'll use that to plug this number back in. And I'm going to do this the easy way. So let's see. Let me start with 1 and 4. So I'm going to go 1, store that into x. Whoops, I got 11. Take the number 1, store it into x. I'll hit enter. That's now stored. My equation is going to be x raised to the 4th minus 12x cubed plus 48x squared minus 64x. So the good news is I'm not going to have to type this in again, right? We can go back and use our memory to help us with that. So I hit enter, and I do not know why I did that twice, but negative 27. So that's this point right here. Did I say negative 27? Yes. Now I'm going to plug a 4 in. So I'll go back to the calculator. I'll say, let's take the number 4, let's store that in X. Hit enter. You can just arrow up and hit that. I don't believe I have that option. So I got to go second, enter, second, enter. There it is. And so this time I got 0. And then I know that when I did my second derivative test, I got the same 0 there. I still got to figure out this one. So we'll take 2, we'll store that in X. Use my deep memory recall, second enter to bring that back. And there it is. And here I get negative 16. All right, so if I'm going to graph that now, so I want to be able to graph this. And so what I know is I've got these 2 points right here that I have to plot. Okay, 4 comma 0 would be right here. I need to change my scale so I can get this in there. And I think I also saw negative 27 earlier. So if I count by 5s, that should be good. So 2 comma negative 16. There's 5, 10, 15, right about there. I remember that we had 0 comma 0 as my y-intercept. So I'll put that point in there. And my relative minimum was at 1 comma negative 27. So let's see, that was a point of inflection, and so was that. Let's see, 5, 10, 15, 20, 25, so 1 comma negative 27 is right about here. That's my relative minimum. All right? Point of inflection, point of inflection. So I need to come down like this, hit that low spot, come back up, and right there my concavity changes. See, this is all concave up. Now it changes to concave down, and then it changes back to concave up. There's a picture of that graph. And it turns out I didn't have to find any other x-intercepts because they just came out in this problem. So I guess I was lucky in that sense. It's really hard to write an equation like this where the x-intercepts are easy to find unless they were some of those key points already, like either a point of inflection or a relative maximum or minimum. So I don't think that's going to be a real focus on questions like this. Finding out where your relative maximums are, where your relative minimums are, where am I concave up, concave down, increasing, decreasing, points of inflection, that's going to be the thing that's important. So anyway, yeah, there we go. All right, so that's what we have for today. I know it's only 2 examples, but these take a while to get through. It makes the video kind of long. And really what we're doing is we're pulling together everything that we've learned up to this point. So let me get you guys a homework assignment, all right? All right, so number 15 continued. We've got Thursday's piece here. It's on page 215. We'll do 16, 19, 31, and 34. You know, again, this looks like a short assignment, but each of these takes a while to get through. So it's probably longer. Well, it's definitely a lot longer than it looks. I would not put this off till the last second. I would try and, you know, get things going as soon as possible on this. All right. All right, that's it. You guys take care. Have a good day. Stay safe. I'll see you later. Bye.